Hi, welcome to clickmyproject.com. The title of our project is A Cluster on a Chip Architecture for High-Throughput Phylogeny Search. The phylogeny search is to find the position of the gene in the phylogeny tree. The phylogeny tree is the evolutionary or history of a particular species with the elaborate details of the search of gene in the phylogeny tree and account for how to implement this search. This paper describes the FPGA based processor architecture for performing a high-throughput phylogeny search. In the FPGA coprocessor architecture consists of 16 parallel elements. This parallel elements is used to reconstruct the phylogeny tree and accelerate the architecture of FPGA based coprocessor architecture and then find the search the phylogeny tree. This phylogeny search is used to find the gene position and details. Also analyze the gene diseases, genetic diseases of the gene. First we have accelerate the architecture of coprocessor and then construct the tree. Tree is constructed by the gene values which is stored into the database. The tree construction is using a depth first search algorithm. This algorithm accounts for how to draw the tree depends on its value and draw the tree which one value is minimum in the database to consider the first node and draw the next node behind this first value. This coprocessor introduced the 16 parallel elements on the chip architecture to perform a high throughput phylogeny search. This 16 parallel element is used to find the gene position and details quickly to retrieve the data. The 16 parallel elements of the chip architecture is speed up the search time on the phylogeny tree. Our architecture exposes a gross-grained parallelism and each parallel element exposes a fine-grained memory parallelism. The parallel computing is used to find a solution on a group of data. That is, the group of data is considered as a cluster and to find a feasible solution for each cluster. This fine-grained memory parallelism is used in the phylogeny search for finding the gene easily and to retrieve the details of the gene quickly. This is the data flow diagram of our project. This data flow diagram has two levels, level 0 and level 1. In level 0, first we have doing data pre-processing. In the data pre-processing, we have extract the dataset into the database. First we have selected dataset. In the dataset having more values and field names. In the extracting models, we have split the dataset by each field name and values and it's stored into the database to the corresponding field. Next we have doing a group construction. In group construction, we have doing two processors. First construct the data and split each attribute. In the construct data values, after we have split each attribute value depends on the data values. We have shown the value attribute each column of the list box. Next level 1. In level 1, the tree is constructed. The tree construction is depends on the database values. First we have collect all attribute value and then construct a tree depends on the data values. We have more field name and values in the data set. We have constructed tree. After that, the attribute values can be stored in each position of the tree. Tree is constructed using the depth first search algorithm. Next we doing the phylogeny search. In the phylogeny search, we have searching a value on the tree. The attribute details is shown then to you depends on your searching value. This is demo of our project, a cluster on a chip architecture for high throughput phylogeny search. Now we enter our project demo. Data pre-processing. This is the first step of our project demo. The data pre-processing, we have extract the dataset into the database. First we have selected database. To click browse and select set name. Then click convert. The data will be stored to our database. Now we exit the data processing. Next we go to the group construction. In the group construction, we have doing construct a data and split attribute. In the construct model, we have grouping the data by the similar value and split attribute model. In this model, we have split the each field name by its value. Now we have seen the constructed data. This is the field name of our data set. Now the split attribute. We have selected 8 columns of data values. The attribute values split in each list box. Then we select any value for tree construction. Select the age in the combo box. The tree will be constructed. The tree is constructed using the depth first search algorithm. The depth first search algorithm is first finding the root value of the tree and finding the left and right subtree of the tree. This is the value of age. The data. This is the age value the database having. Now we exit that. Then we go to phylogeny search. The phylogeny search, we have select one field name. For example, age. Then view the age value have shown in the combo box. If you note the details of that value, to select that and click the view button. For example, we select 37 and view This is the detail of age 37%. Now we exit the Phylogeny search. Now the Phylogeny search is completed, and after that we are going to analysis. In this analysis phase, we have analyzed the system analysis and service analysis. System analysis depends on the performance of the CPU. Now the analysis button is click. This is the performance analysis of our project. The green color is shown the system analysis and blue color is shown the service analysis. Thank you.